Water exerts pressure on any surface that it contacts, and the magnitude of that pressure is proportional to the depth h. For a dam to do its job, it must resist the forces generated by these pressures. Common strategies for doing so include buttress dams, embankment dams, and arch dams. To make ponds for mills and to control water elevation in rivers, another strategy is often used. It consists of vertical piers with straight horizontal members between them. The water pressure that pushes against these horizontal members is carried by bending, and so these members function as beams. We can build a dam that works in this way using a flat sheet of cardstock to represent the horizontal beams. We insert the ends of the sheet into the grooves of the plexiglass box so that they can support it, like the piers of a real dam. For simplicity, we use marbles to represent the water. Which part of the dam do you think will collapse first? The top, the middle, the bottom? As the depth of the model water increases, the cardstock bends until the dam collapses, unable to resist the lateral loads. The marble depth that produced failure is 4 centimeters, and as you can see, failure started at the bottom. That should not be surprising, since the pressure is greatest there. Another strategy for making a dam is to use an arch laid on its side, like this. If you watched our arches and chains video, you will know that arches can be very effective in load carrying and that they carry load by compression. To build an arch dam, we make the cardstock panel a little longer than the distance between the grooves. Then when we install it, it automatically curves into an arch shape. As we pour in the marbles, raising the model water level, the cardstock resists the resulting pressure by compression, just like an arch. As you can see, an arch shape like this can carry a greater depth of marbles than our earlier flat design. Even so, the arch dam also eventually collapses when the model water level reaches a depth of 9 centimeters. As before, failure begins at the bottom of the dam because the pressure is greatest there. As this model has demonstrated, an arch-shaped dam can support a much greater depth of marbles or water than a corresponding flat one. That is why arch dams are so often used for big, tall dams. As a side note, you might be interested to know that the concrete in tall arch dams is usually made thicker towards the bottom so that it can better resist the higher water pressures there.